Retirement planning, time value of money review. Time value of money, retirement planning. Okay, the 3 steps for the calculations for retirement planning and education planning are the same. In step number 1, we inflate the current cash flow amount or expense for the number of years until required. That is the start of retirement or university, it's in the future, to determine the first year's cash flow need. This step uses the rate of inflation only. So what that's saying is that if we have income that we want to be in retirement of, say, $45,000 in today's dollars, but we're not planning to retire for 15 or 20 years, and we want to preserve the purchasing power of that income in today's dollars, but there's inflation, we need to know what that $45,000 will be worth in the future. So step number 1 is just a future value calculation, and we're using the rate of inflation as the discount rate, okay? And the N is the number of years until retirement begins. Step number 2, we're going to calculate the amount needed at the beginning of retirement in university, i.e. not today, to fund the inflation-adjusted cash flow required for the client to maintain purchasing power throughout the anticipated retirement period. This step uses the real inflation-adjusted rate of return and is almost always calculated as an annuity due, i.e. in the beginning mode. So what this step number 2 is saying, we're going to retire for 20 years of inflation-adjusted income. Today's dollars, we want to preserve $45,000 of purchasing power. So step number 1, we calculated the future value. That becomes our payment. That's how much we want to receive every year. But again, it's inflation adjusted, so it'll start at a certain amount, but that amount will be going up with the rate of inflation. At the same time, you're going to, in these type of questions, we want retirement fully funded at the beginning of retirement. So you have this lump sum available to you. You're taking a withdrawal at the beginning of the year. There's balance left over. On that balance, you're going to earn investment return. However, there's also inflation. So in that case, for the discount rate, we're going to use the real inflation adjusted rate of return, and we'll see that later on in the slides in more detail. In step number 3, so now we know how much that we want lump sum at the beginning of our retirement, and again, that's going to be at some time in the future. The third step is really to solve, well, how much would you need today? So it's just a present value calculation, or indeed we could calculate how much we could save at the end of each month or at the end of each year. Nevertheless, we know how much we need at the beginning of retirement, but we need to present value back and set up a savings plan, monthly or annual, or understanding how much we would need today. Okay, so those are the 3 steps. Step number 1, inflate the current cash flow amount to when the retirement begins. Step number 2, that becomes your inflation adjusted payment that you're going to receive for the duration of retirement. The discount rate, we're going to use the real adjusted rate of return. And in step number 3, how much do we need today to invest to reach that target in the future? And again, just want to point out that in this step, we'll be using the investment rate or discount rate. So each of the steps is using a different discount rate. Step number 1, rate of inflation. Step number 2, inflation adjusted rate of return. Step number 3, we use the investment return. So let us work through an example of a present value annuity due of a serial payment, because we're reviewing time value of money in retirement planning. And indeed, in the PowerPoint here, I have embedded an Excel sheet. This should be available in the learning management system, which has the time value of money calculations in Excel to match, which is in the slides. Okay, so in this example, assume John wants to retire 18 years from now with inflation adjusted equivalent of $45,000 additional annual income. This is above benefits provided by a government or employer pension. Payments at the beginning of each year. So we see that BGN mode. Okay. As John and the financial professional discuss his retirement, the two agree to plan for 20 years of inflation-adjusted income in retirement. Annual inflation is stable at 2.5%. John's portfolio is earning 6% annualized after fees. So the investment return we always want to look at is after fees. Fees are negative performance. How much money will John need today? See, that's today, present value, if he wants the entire amount in place at the beginning of his retirement. How much, and then we can follow that up with how much money will John need to save every year or month starting today if he wants the entire amount in place at the beginning of the retirement. So indeed, those are the steps that I was just describing. Up here are the 3 steps. Here we're putting it into example, assuming John wants to retire 18 years from now, inflation adjusted equivalent of 45,000, plan to retire for 20 years, annual inflation 2.5%, portfolio earning 6%, and so how much does he need today, or indeed how much will he have to save every year or month? And that's usually at the end of the year. You get a bonus, or the end of the month, you get your salary. So it either becomes how much you need today, or what is the savings plan required to meet that retirement goal. So not going to spend a lot of time on this slide, but just want to point out now with regards to the question, John has $45,000 in today's purchasing power that he wants to preserve, plans to retire 18 years from now. So we're going to calculate the future value, and that becomes the payment that he wants for his 20 years of inflation adjusted income in retirement. So step number 1, today's dollars into the future value calculation. Step number 1, what is $45,000 in today's dollars worth 18 years from now? So, of course, we can use the algebra. Future value equals present value times 1 plus I to the n. The present value is $45,000, and the I is the 2.5 inflation rate. So if I just bring my calculator in here, that's going to be 1 plus 0.025, y to the x 18 years from now, and we're going to multiply that by $45,000. So $45,000 today has the same purchasing power 18 years from now as $70,184.64. Indeed, we could round that to $70,185. If we want to use the calculator, then it's also very easy to do. Mode is ending mode, PY equals 1. Let's just check that. Second PY equals 1. And N equals 18, so moving left to right, 18 N, 2.5 on the IY. Present value is 45,000. We're going to make that negative, and 0 payment, and we're going to compute the future value, 70,184.64. So that's the payment we want at the beginning of the first year of retirement, 18 years from now. So just back to our little graphic here, because some people are more visual than others. So we started with the $45,000 in today's purchasing that we want to preserve, retire 18 years from now. So we just calculated the future value. Future value equals present value times 1 plus I to the n. And we're using the rate of inflation, 2.5%. So $70,184.64, 18 years from now, has the same purchasing power of $45,000 today. And that is going to become your payment at the beginning of the first year of retirement. But that payment is going to go up during the 20 years because it's inflation adjusted income in retirement. We're going to assume the same 2.5% rate of inflation. So there we are. Step 1 is done. Step number 2 is to determine the amount needed to fund the next 20 years of John's inflation-adjusted retirement income. So recall, as John and the financial professional discuss his retirement, the two agree to plan for 20 years of inflation-adjusted income. Annual inflation is 2.5%, and John's portfolio is earning 6%. So the first thing that we need to do is we need to use the Fisher equation to calculate our discount rate, because we need to use the real rate, because to maintain the purchasing power, the negative impact of inflation must be addressed. And we do that by using the real rate as our discount rate. This is a present value annuity due of a serial payment type question, okay? So we can see that the investment return is 6%, the inflation is 2.5%. So 1.06 divided by 1.025 minus 1 times 100 gives us a discount rate of 3.4146. So that's always step number 1. If we want to bring up the calculator very quickly to do that, very simple calculation, speedy, 1.06 divided by 1.025 minus 1, and we multiply by 100, and we can see here 3.4146. So that's what we're using as the discount rate. Okay, so again, the calculator has to be in the beginning mode because these payments are going to become at the beginning of every year. They're annual payments, 20 years of inflation of retirement. And so recall the payment is the $70,185 that we calculated in step one, $45,000 today. 18 years from now, when retirement is going to begin, is this equivalent to $70,185. There is no future value because the retirement is over. So this is just calculate a present value of an annuity due, and we'll bring up the calculator. So we're not in the beginning mode. So we're going to do second begin, second enter, just clear that off. So then we'll check that second PY. Oops, it seems to be in a monthly mode there. So we need to, that's always good to check. So I'm going to make that annual. There we go. So starting left to right, so it's 20N, and the discount rate is 3.4146 is our IY. We're calculating the present value annuity due. The payment is $70,185. That's our payment, and there is no future value because the retirement is over. We compute the present value annuity due, $1,039,000. We'll round it to $575. So just catching up on our graphic. So John has $45,000 in today's dollars that purchasing power he wants to have in retirement 18 years from now. So step number one, we calculated the future value. We just used the rate of inflation, 2.5% as our IY. So $45,000 today, equivalent to $70,184. That becomes the payment that John wants to receive at the beginning of the 20 years of inflation adjusted retirement. So that amount is actually going to go up $70,000 by 2.5% every year. And so what we're doing in step number two is calculating how much he has to have at the beginning of retirement to have it fully funded when he's earning 6% net of fees on his investment account and inflation is at 2.5%. We calculated that to be $1,039,575. So the third step, we're going to see, well, how much would that be in today's dollars? So it's just a straight out present value calculation. In this step, recall for the discount rate, we used the real inflation adjusted return using the Fisher equation. Here, we're going to use just the investment rate as the discount rate because it's a save and invest. We're starting today to save and invest. We're going to use the discount rate, and we're retiring 18 years from now. So we can calculate three calculations. Number one, how much do we need today as a lump sum? Number two, we can calculate how much do we need to save at the end of every year. Say we get a bonus, so we can set up a savings plan. Or number three, indeed, we can even calculate how much we need to save at the end of every month as a forced savings plan. And those are the three steps that we're going through, and we're at the end of step two. Now we're moving into step three. So step three is to determine the amount needed today to meet the goal 18 years from now, or determine the amount of monthly or yearly savings. So in this case, we need to change the calculator back to the ending mode. If we want to know the lump sum available we needed today, it's going to be PY equals 1, N equals 18 years from now. Because we're starting to save today, we're going to retire in 18 years. As I mentioned, it's a savings and investing rate that we're going to use. There's no payment because we're just calculating the lump sum. The future value is the $1,039,575. So indeed, this is just a present value calculation. The algebra, present value equals future value divided by 1 plus I to the n. So for those of you like algebra, it's a very simple calculation. We don't really need the financial calculator, but indeed, let's bring up the financial calculator. We can see we're in the beginning mode here, so we want to change that out. Second begin, second enter, and we're out of the beginning mode. Going to check second PY. Yes, we're in 1. So it's 18 years from now that we want to retire. We're using the 6% investment rate net of fees. There is no payment, and the future value that we want to have in place at the beginning of our retirement, $1,039,575 future value, and we compute the present value. So we need $364,208. Can round that up, $209. If we have that today, and we can save and invest at 6% net of fees, Then 18 years from now, we'll have $1,039,575, which would be available to fund 20 years of retirement, starting with that payment of $70,000 plus, which is the same as the purchasing power of $45,000 today that we want to preserve. Okay. So the other thing that we can do in step 3 is not only determine the amount that is needed today to fund the to meet the goal 18 years from now, but we can also calculate it in terms of a monthly or yearly savings target. So just moving on to the next slide, step number 3, on the left-hand side here, we can see what is the annual savings that you would need to do for 18 years. Again, save and invest using the 6% discount rate. The future value is that $1,039,575. And so we're going to compute the annual payment. Let's say, and this isn't the ending mode, someone gets an annual bonus and they want to have a forced savings plan setting aside certain amount at the end of every year. Now that bonus may increase as well, or it could go down, but nevertheless, in terms of planning purposes, we could calculate, well, to meet that retirement goal of having $1,039,575 in place 18 years from now, how much would you have to save on an annual basis at the end of this year and every year for 18 years to meet that goal? Okay, so we can bring up the calculator, and we're in the ending mode. That's correct. So we're going to just check second PY. Yes, we're in 1. So that's 18 years is the N. 6% is the discount rate. There's no present value because we're starting to save at the end of this and every year. We're going to compute the payment, and the future value is the $1,039,575 future value, and compute the payment. So we need to save the beginning of this year, each and every year for 18 years, $33,637. Okay. So the next thing that we can do is we can just convert that into a monthly. How much do we, if we wanted to have a forced monthly savings plan, well, then we'd have to change the PY to 12. Okay, so how do we do that? Second PY, we're going to change that to monthly, hit enter, and now it's 18 years from now, so we can do 18, second, and N gives us our 216, or as you know, you can see N is XPY, X is the years, PY is the periods per year, so 18 years times monthly, 216. Okay, so that's just a couple of ways that you can do it. You can do 18, second, and N if you've set up the parameter PY equals 12. Okay, so that is our N. It's the same 6IY. The 1,033,9,575, 1,039,575 is our future value. There's no present value because we're starting to save a monthly savings plan, and we're going to compute the payment. We need to save $2,600 and round it to $84. Okay, so just finishing up with this last slide, just a quick review, the 3 steps for the calculations for retirement planning. Step number 1, we're going to inflate the current cash flow for the number of years until required. So in this case, it was $45,000 that we inflated for 18 years, equivalent of $70,185. That becomes our payment that we want at the beginning of retirement for each and every year of 20 years, but it's inflation adjusted, so that $70,184 will go up by 2.5% a year. And we want to calculate what is the amount that is we want at the beginning of retirement to fully fund it. So we know that at the beginning of first year, we're going to take some out. We're going to have balance remaining. On that balance remaining, we're going to earn 6% investment rate net of fees, but the discount rate that we use in step number 2 uses the real inflation adjusted rate of return, and it's always calculated as an annuity due, i.e. in the beginning mode, present value of annuity due. So we calculated that we needed $1,039,575 at 18 years from now to fund 20 years of inflation adjusted income in retirement, where the first payment is $70,000, $185, which is the equivalent of $45,000 today. And so the third step was just saying, okay, we need that $1,039,575 18 years from now. How much do we need today? If we had all of it today to fully fund it, we'd need $364,209. Or we could calculate it as an annual end of the year savings plan. We calculated that we would have to save $33,637 at the end of this year and every year for 18 years at a 6% compounding rate of return to have $1,039,575 in place 18 years from now. Or indeed, we could translate that into a monthly end-of-month savings plan, $2,684. So that, if you have taken the personal financial management course with Chapter 2, Time Value of Money, this should be familiar to you and a review. However, people that are jumping in and taking the retirement planning course, it was important to go through these 3-step calculations for retirement planning. This is very common steps that we take, and you'll see a number of practice questions indeed in the textbook and in end of chapter practice as well, based on these 3 steps calculations for retirement planning. Okay, thank you.